The next step is to remove words that are of too high frequency or too low frequency. A very high frequency word does not differentiate between the documents very well. If you have a word that occurs in a third of the collection, for example, it's not a discriminator. It does not help you determine one document from another. It's not good for retrieval. On the other hand, a word that only occurs once or twice or 3 or 4 times even is unlikely to be ever used as a search term. It's a judgment call on the low frequency words because some of them might be very specific in a very specific discipline, but often they're spelling errors or they're one-offs that really aren't indicative of anything. The first calculation is to determine the minimum number of times a word should occur, and that's min divisor, which I've got set to 250. That's divided into max docs, and we get the min word frequency. So in this case, since we're mainly using 1,000 documents, the result would be 4. In other words, if a word occurs fewer than 4 times, we don't want it. You can adjust these and get different results, of course. You can keep all the words, or you can raise the threshold even higher, that it has to occur 5 or 10 times. You get different results that way, but of course you increase your processing time. The other one is the maximum number of times a word should occur. If it occurs more than that, then you don't want it. The number I've got here is 3, which means when you divide it into max docs, if the word occurs in more than a third of the collection, that's pretty generous, we want to get rid of it. We should probably set that a lot lower. Let's say 10. So if it occurs in more than 100 documents out of 1,000, it's probably not a very good indexing term. These are judgment calls. You can set them as you want. The program, the script here, then writes out some of this information and exports it into the environment so they can be read by programs. And then we finally get down here to where we're actually going to process it. Frequencyfilter.mumps is a program that will look at the vocabulary, and it will eliminate words based on, it'll decide based on the minimum word frequency and the maximum word frequency, which you can see are being passed as parameters to the program. These $ mid-word frequency be filled in when it actually runs with a number. And likewise here. The input is coming from stemmed vocabulary.temp, and the output is going to go to deleted words for frequency. Now, to look at the file there, stemmed vocabulary.temp, if you don't remember it. Whoops. All right, move. What am I typing? It is an alphabetical list of the words with the count. It was a result of running sort and unique, and it gives the count of the number of times each word exists in the stemmed and initially stop listed vocabulary. And it's not ordered by frequency; it's ordered alphabetically. And some of them occur quite frequently. Some occur very infrequently. Okay. The output of that will be 2 things, one of which will be, as we will see, a list of what was deleted, and it also modifies the stop list, creates a new stop list, as a matter of fact. Let's look at the program frequency filter .mumps. And it's a relatively short program. It picks up the 2 parameters. %1 is the first parameter, %2 is the second parameter. It opens up stop.words and clubbers stop.words. The old contents of stop.words are lost, and we're going to create a new stop list. If you remember, stop.words was created by copying in from another file, so the original file is still preserved. This was a stop.words is just really a temporary file. Initially, it was our initial set of stop words. Now it's going to be our constructed set of stop list words. We do forever. We read a line. We quit if there's no more input. We remove the extraneous blanks. If you remember in that file, stemmed vocabulary.temp, there were a number of blanks prior to the number. The number was right justified in a field. We don't want those blanks because they mess up the $piece function. So this gets rid of duplicate blanks. If there's 2 or 3 blanks, they're replaced by just 1 blank. So it eliminates the extra blanks. We set C, which is the count, equal to the first piece on the line. I abbreviated piece here as P. That's the $piece function. So we go through the line and we look for the first thing delimited by a blank, and the first thing delimited by a blank will be the count. Then we ask the question: is the count less than the minimum? If it is, we switch to unit number 1 and we write out the second piece. The second piece being the word. The word will be written out. Then we switch back to unit 1 and we write out we're deleting it for because it was a low frequency word. We write out the word and we write out the count. This will be in that output file of deleted words. But the other one is, of course, stop.words. It'll just simply have the word in it. The word is the only thing that will be in the stop.words file. Likewise, we do the same thing if the count is greater than the maximum. And we write out and we say it's being deleted for high when it gets written to the output file. And the word itself is written to stop.words. Okay. If we go back up here, and this will be the output file down here. That'll contain a list of what stop.words is also an output file, but the second file also gives us why it was deleted, whether it was low or high, and what the actual count was. Whereas stop.words will simply be a list of words. We extract the count and so forth and so on and print it out. There's a lot of echoing of the content here. Now we're going to run stop.mumps again. And the input is going to be that intermediate file, initial stemmed docs.temp that we created up above. And the output will be our more or less final file, stemmed docs.temp. Now, these are temporary because they're only going to be used during the run. They're not they won't be used again after this run, so we call them temporary. Stop.mumps, if you recall, we have run it before. Looks like this. We load the contents of stop.words into the container. We read input. We extract, if with no more input, of course, we break, we exit. We skip the first two because those are these are the documents we're reading in. The first two items on it will be the offset and the document number. Once we've read those of which we write out directly, and then we go through all of the words in the document on the line, in other words, which will be W sub J 1, 2, 3, 4, 5, 6, up to whatever the top value is. We then, it still converts them to lowercase, but they already are lowercase. And we check to see if the words are in the stop list container. If they're not in the stop list container, see the quote, single quote sign, that's the not sign, we write the word out. So the output will be the documents minus these new stop words. These new stop words will be the high-frequency words and the low-frequency words. This is in addition to the initial set of stop words that went into creating the file that we're using as input, the common words and, or, for, and things like that. They've already been removed. Now we're removing our own stop words, words which we think are of too high frequency or too low frequency. All right, going back here. After we've done that, this is going to be the output stem-docs.temp. We then want, we're going to run that through word list, which is going to give us basically a vocabulary. Word list.mumps. And all it does is it simply reads in the document into the array W. I use W all the way through here. There's nothing more. We quit. We skip the first two items because they're numbers. We don't care about them. And we write out the word, one word per line. So we will have a file that consists of all the words, all the instances of all the words. Okay, what do we do with that? Well, that goes to words.temp. Then we will sort words.temp. We'll run it through the sort program. And since they're words, they'll be alphabetically sort. The output of the sort program will be piped into unique. And unique will count them, the -C option, and then we will have vocabulary.temp. So what we're going to end up here is vocabulary.temp, which will be a list of the words alphabetically, and it will give the count of each of the words. This is our final, at least at this point in time, this is our vocabulary. The other thing we're getting out of here is stemmed docs.temp. This will be our working collection. This is the working collection of documents that we're going to be running. Let's see. Yes, and there's, well, I should move the exit here to after the actual program. All right, so let's give it a try and see what happens. Look at the different parts of it. And I'll give it 1,000. All right, well, let's look at vocabulary.temp. And these are the words that have remained. You'll notice in here that the counts are, there's no more single words that occur once. The minimum number there appears to be 4 as we're going through here. Yes, and there's no really high counts in the other thing. The next thing would be, of course, what is it? Stemmed. Let's go into the. Let's go ahead and look at the file names. Vocabulary.temp we've looked at. Let's look at the output here. Where is the output? Stemdocs.temp. Trying to remember the exact name of it. This is what the final collection of the documents is going to look like. This is what we're going to process. You notice they're getting smaller. Each document is now shorter because we are pulling words out, a lot of the one-off words and so forth. The other one there is the actual, the deleted for frequency. What is the name of that program? Right, deleted words for frequency. That was, in fact, the name of it. And here we can see the words that were deleted and why they were deleted. Low means they were deleted because they were below the cutoff. High one means that they were above the cutoff. And our cutoff was pretty high. I don't know if we actually got any of the high ones. And the actual count they occurred in there. And let me try looking to see if there were any high ones in there. Yeah, there's one. Acid occurred 119 times. Why don't we just grep it and say grep high deleted. So search for all those instances. Yeah, there were quite a few. How many altogether? We'll run that through word count. 93. 93 words were deleted because they exceeded our high threshold, which is probably a pretty good number. So there we are. Now we have got a vocabulary, and we've got a working collection that we can now proceed to make the document term matrix from.